Section 8.2 is L'Hopital's rule. So we're going to be using L'Hopital when we have an indeterminate form. So if the functions f of x and g of x are both 0 at x equals a, then the limit as x approaches a of f of x over g of x cannot be found by substituting x equals a. So in other words, if I put in f of a over g of a, I will get an indeterminate form of 0 over 0, which is a meaningless expression known as indeterminate. So what do? So L'Hopital's rule says that suppose that f of a and g of a equals 0, and that f prime of a and g prime of a exist, and that g prime of a at least does not equal 0, then finding the limit as x approaches a of f of x over g of x is f prime of a over g prime of a. I would put an in-between step in. I would say that the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of a over g prime of a, and if now I'm messing myself up. F prime of x over g prime of x, still looking for the limit, and in this case now I can substitute in a to get f prime of a over g prime of a. So that's L'Hopital's rule. Let's do one. So if I plug in 0 for x, I would get root 4 minus 2 over 0, which is 0 over 0, or an indeterminate form. So to solve this limit, I am going to take the limit as x approaches 0 of the derivative of the top, 1/2, 4 plus x to the negative 1/2 over 1. I'm going to rewrite this as the limit as x approaches 0 of 1 over 2 root 4 plus x. And now using just substitution, I can actually calculate this limit, which is 1/4. So pretty easy to find the limit when we're dealing with an indeterminate form. All right, next slide. This is another form of L'Hopital's rule. Again, they've shown that in-between step, but now instead of x approaching 0, it's x approaches any value a, and it's on a particular open interval. So sometimes we can limit the interval that we're looking at and still use L'Hopital's rule. Okay, let's do a couple more. These are all printed out with a one-sided limit. So the limit as x approaches 0 from the left of sine x over 2x. Again, substituting in 0 for this, we would get 0 over 0. Applying L'Hopital, the derivative of sine x is cos x, the derivative of 2x is 2. Now I can plug in 0, and I get 1/2. Now, another indeterminate form is infinity over infinity. So we can identify the indeterminate form by using L'Hopital. So the first thing we need to look at is if I plug pi in, the numerator and denominator are discontinuous at x equals pi. So we have to look at one-sided limits. To apply L'Hopital, we can choose the interval to be any open interval containing pi. So the limit as x approaches pi from the left is infinity over infinity. So we're going to differentiate. The derivative of cosecant is negative cosecant cotan. The derivative of 1 plus cotan is negative cosecant squared. This can be simplified. One of the cosecants can cross off on top with 1 on the bottom. Cotan over cosecant is cosine. So the limit as x approaches pi from the left of cosine is negative 1. The right-hand limit is the same. Therefore, the two-sided limit is equal to negative 1. That's really it. We're going to do a few problems in class, but there's not much more to this than that we're going to do.